Good morning to all. Myself, Dr. Arun Agamia from Aerospace Engineering Department. Today, I am going to take one topic from Aerospace Propulsion subject for second year students. So, in that topic, it will be fall under the Unit 3 Fundamentals of Gas Turbine Engines. So, the topic of this today video is performance characteristics of turbine engines. So in that turbine engines, it will be under the category of gas turbine engines. So in that gas turbine engines, it can be classified into many types like turbojet, turboprop, turbofan, ramjet, scramjet. So now we are going to elaborately discuss about the performance characteristics of turbine-based engines. So in that turbine-based engines, so what are all the performance are expectation. So in that empathy part, so in that expectations, it will be met the following uh, criteria. First one is reliable thrust delivery. Second one is efficiency target, and third one is optional impact, and fourth one is health monitoring. So in that reliable thrust delivery, it will be the varying with the flight conditions and altitude. For example, passenger flight, it will be attain some altitude. So for example, the fighter jet, it will be attain some altitude. So in that efficiency target, so mostly it will be depend on the thrust to weight ratio based on the fuel economy. And next one is the operational impact. So in that operational impact, it will be directly influence the aircraft range, speed, and operating cost. And next one is the consistent indicator for health monitoring. So we will routine check for the aircraft maintenance. Next one is the key parameter for performance parameter. First one is a thrust. It is a forward force. It can be created by the propeller. And next one is a specific fuel consumption. So it will be depend on the flow rate for unit thrust. Next one is a overall pressure ratio. So in that overall pressure ratio, it will be calculated by ratio of compressor outlet to the inlet. And next one is a turbine inlet temperature TAT. So the more amount of temperature it will be entering to the turbine area. Bypass ratio means the ratio of bypass air to the core airflow. So atmospheric air directly fall to the compressor region. And next one is the thermal efficiency. It will be convert the chemical energy into mechanical energy. And the next one is the effectiveness propulsive efficiency. It will be convert the mechanical power into the thrust power. So next ideate part, the visualizing performance, a typical engine graphs. It can be plotted between the four different categories. The first one is thrust versus flight Mach number. So the thrust increases, the Mach number also increases. So next one is specific fuel consumption versus thrust. So in that it will be vary with based on the flying conditions and flight conditions. Next one is pressure ratio and compressor speed. So in that it is also the based on the turbine blades and boundary. Next one is the turbine inlet temperature and time. So it will be based on the it can be useful to track the engine health, material degradation, and performance. Next one is the thrust versus Mach number. So in that thrust versus Mach number, it can be taken from the low Mach number like subsonic Mach number only. So during these cases, we will achieve the turbofan. It will achieve a good thrust compared to the other flights. Next one is a specific fuel consumption versus thrust. So here the specific fuel consumption decreases with increasing the thrust. The optimal specific fuel consumption, it will be occur in the 80 to 100 kilonewton thrust for turbofan engines. Next one is by calculating the specific fuel consumption. So given parameter is thrust and fuel flow rate is 0.5 kg per second, and operating condition is cruise flight. So in that calculation, we will calculate by the SFC equal to fuel flow by thrust. So fuel flow is 0.5 kg per second and divided by 100. So finally, we will get the 0.05 kg. So it can be counted to the standard unit. So finally, we will get the 18 kg. So this is a specific fuel consumption, and why these parameters are matter. So in that parameters, it will be utilize the following characteristics. First one is the material challenges, environmental goals, engine health and monitoring, and operational optimization. So these are all the things we need to check all the parameters before taking the aircraft. So thank you. So we will catch you on next topic on next video.